Why can light pass straight through glass while the glass itself seems not to glow at all? In the energy filament theory, glass is made of filaments whose internal channels let light's rhythm travel through and come out the other side, instead of forcing that rhythm to stay and be re-emitted as the glass's own light. Think about what actually happens at a window on a sunny day. Sunlight comes in, your tables, books and faces all light up, shadows appear, colors pop. And yet the pane itself looks almost invisible apart from a bit of glare and reflection, as if it just stepped aside and let the light walk through. In this picture, a beam of light hitting any material always faces three possible fates. Parts of its pattern can be swallowed and turned into extra internal motion, which shows up as heat. Parts of it can be taken in and then re-emitted in the material's favorite timing, which shows up as its own glow or color. The rest can be picked up by the internal structures and passed on to the far side, which is what we call transmission. Different materials are not magic categories. They are just different ways of splitting one incoming light pattern into these three paths. Think of wood or cloth first. On the microscopic level, they are like a chaotic bundle of twisted threads, with their filaments pointing every which way and their internal channels constantly bending and dead endings. When a light rhythm tries to enter, it quickly runs into a maze. The energy sea inside those structures has a hard time carrying that pattern cleanly from one side to the other. So most of it gets trapped, scrambled, or handed off to the material's own natural beats instead. Some of the incoming pattern is chewed up into heat, so the object warms. Some of it is reissued as the particular rhythms that the material's atoms like to use, which is what you see as the color of the wood or fabric. Very little leaves as a faithful copy of the original pattern in a straight line. So you say the object is opaque. Glass is built differently. In this view, its internal filaments are arranged in a more orderly way, with many semi-regular channels that, while not perfectly straight, are far smoother routes for the light rhythm to follow. When a beam hits a glass surface, the energy sea there still has to decide how to split the pattern. And all three paths still exist, but the balance is different. A small portion of the rhythm bounces, giving you the reflections and glaring you notice when you catch the pane at the right angle. Another small piece is eaten and turned into heat, which is why a sunlit window can feel warm to the touch. The main share, though, is picked up by those better aligned internal channels and relayed step by step across the thickness of the glass, only to be handed back to the outside energy sea on the far side. That outgoing pattern is close enough to the incoming one that you recognize it as the same light, now lighting up objects behind the pane. A helpful way to picture it is to imagine three kinds of workers handling packages. One kind of worker opens every box and keeps what is inside, turning packages into private activities, that is absorption into heat. Another kind opens the box, repacks it into their own brand, then sends that out. That is the material eating the incoming light and re-emitting its own preferred rhythm as color. The last kind barely opens the box at all and just carries it from one door to the other. That is transmission. Opaque materials behave like the first two workers, busy eating and rebranding. Glass behaves mostly like the third, acting as a courier. That is why you notice the things behind it lighting up much more than you notice any glow from the glass itself. This does not mean the glass can never shine. Heat it up enough and those internal loops are forced into a frantic workload. They now have so much excess energy that the eat and pass on channels are not enough to keep them stable. So they started using their own emission beats in a big way. The second path suddenly dominates, and the glass becomes visibly red or white hot. At that point it has stopped behaving mainly as a courier and has become a genuine light source in its own right. In this picture, the difference between transparent and opaque is not a sharp label. It is a statement about which of the three paths wins. Materials that excel at swallowing and reissuing patterns look solid and colored. Materials like glass that excel at pushing the incoming rhythm through their internal channels look clear, even though they are quietly working hard to relay those patterns. What you experience as transparency is really just the world behind the glass being allowed to borrow the sun's rhythm with very little editing by the windows in between. Tap follow, share it on New Physics, Clear Universe.